Hello, friends. Happy to have you here with me today. So we're working today in chapter 18, and that's where Daniel Liang, in his Intro to Java Programming book, introduces the concept of recursion. Now, one of the early listings shows you how to do a recursive definition of a factorial. And then in the homework assignment, exercise 2, it then follows up and it says, hey, what would happen if we did that? Oh, where did it, too far. There we go. What would happen if we used 18.1 if we did this with a big integer? So let's go ahead and let's get started with that today. So in here, I'm going to make a new project. And I'm going to call this one Liang Chapter 18. Exercises. Use the default Java runtime environment. Go ahead and get this started up. We'll have inside our source folder, I'll do a new package, and I'm going to call this Chapter 18 Exercise 01. Now, inside that, I create a same class, a class with a very similar name, Chapter 18 Exercise 01. And this one we will include a public static void main. Now, what I've got here is almost exactly what we're going to need. So I'm going to grab, this is the listing 1 from Daniel Liang's Introduction to Java Programming, Chapter 18, listing 01. And so we can just come in and we can grab this code. Whoops. I'm going to just copy that, and then we can paste it in here. Now, we do have to make some modifications though, right? So let's do this. Let's go and let's change our input. Let's see exactly what we can get away with. So let's come down here and let's change int to big integer, our input. How about user input equals new big integer, which has the value in plus memory serves. That should create. Okay, now I can do that. And now user input, and that there. And I'm going to rename, actually, this is the only place this is used. So I'm going to call this int user input. Should have, and now we use user input here. Now, it complains, it says, hey, that's not the correct line. So what I need to do is change the method to factorial, passing in a big integer. Now, down here, I'm going to use user input. Not quite as elegant, but it'll work. It'll work. And it refactored it all the way across. So now, we have to change this just a little bit. So dot equals, let's see. Let's come here, Java big integer compare. Yeah, so what we want, we're looking for the ones if they're equal to 0. So the text on this is going to be compared to, all right, so we should be able to, let's pop in here, dot user input dot compare to, and now we want zero. Okay. Now, user input, what we need to do here is dot and then we'll do PBwJ dot 1. Yeah. All right, so factorial, something, it's not happy about something. Somewhere I've missed something. Maybe that's it. Yep. So we probably need to change the return type to be in big integer. Okay. What else we got for problems? I see. And so here, 1. Yeah. All right. So let's just give this a shot. It's usually not a good idea to run for that long without giving it a shot. But 4:24, let's pop back to Daniel's book. And in the case study, he actually gives us a couple of examples that we can test right quick. So 4 gives us 24. He says 10 should give us 3628800. So let's run it again. Let's try 10. 3628800. Hey, you know what? That'll work. So now let's run it again, and let's punch in 100. I'm going to have to take the computer's word for it that it got that right, because I'll be honest. No, I can't get my mind wrapped around that number. But the code basically is doing the same thing. The concept, though, is you've got to be a little more careful with how you're doing it, because big integers are stored as strings, which are immutable, and that means they can't be changed once they get created. And so that's what makes them a little more challenging to use. But the fun thing I love about big integers is now you truly have an infinite processing and problem solving capability. Literally, you can make numbers as big as you can imagine it, and even larger possibly. And there really is, until you run out of hard drive space, no limitation on that. So anyway, with that, I thank you all for spending a little time with me today, and I wish you all happy programming. Have a wonderful day.